The cross product only lives in 3 space. Its rather complicated formula can be memorized using cofactor expansion, unless you forgot about determinants. Note that, unlike his cousin dot product, cross product produces a vector. This is the magical part. The cross product produces a vector perpendicular to both originals. That is why it is so useful for planes, areas, and normals. The cross product is anti-commutative. Switch the order, and the sign flips. So the cross product is a little moody. Change the order of the guests, and the whole party goes backward. Memorize the cycle I to j to k to I. Go clockwise and the answer is positive. Go against the clock and the sign turns negative. It is basically a one-way roundabout for vectors. This is one of those places where parentheses are not decoration. Cross product does not behave like ordinary multiplication. Ignore the grouping, and the algebra gets confusing. The size of the cross product is not random. It measures area. So the cross product is secretly a geometry machine wearing algebra clothing, like a ninja with a calculator. A triangle only gets half the area because a parallelogram is basically 2 matching triangles glued together. The scalar triple product looks scary, but it is just a determinant in disguise. Once you spot the disguise, the problem gets much less dramatic, like a villain unmasking and turning out to be an already defeated enemy. Cyclic shifts are friendly here. Rotate the order in a cycle, and the value stays the same. It is the mathematical version of musical chairs where nobody actually loses a seat. This is a beautiful connection. Determinants point to geometric quantities. They measure area and volume, which means the determinant is basically a geometry tool. The big idea is simple. Volume equals base times height. The cross product gives the base area, and the dot product sneaks in the height. Put them together and boom! The determinant appears like a magician pulling a rabbit out of a matrix. The scalar triple product measures signed volume, and the absolute value gives actual volume. So if your answer comes out negative, do not panic. Volume cannot be negative unless your parallelepiped owes money. If the volume is 0, the vectors do not build a real 3D box. They collapse into a plane. It is like trying to pitch a tent and discovering all the poles are having a lazy day. A plane is easy once you have a normal vector. The cross product erects that normal vector like a master builder. This is where parametric equations stop being polite and start negotiating. We make the coordinates equal and then let row reduction settle the argument, like a referee with a matrix. The zero row tells us the system is consistent, not broken. Then the pivot rows reveal the parameters. It is like a detective story where the matrix finally confesses everything. Skew lines are the awkward strangers of 3-space. They are not parallel, but they still refuse to meet. The cross product helps us measure the smallest gap between them, like a cosmic ruler for social distancing. The shortest segment between skew lines is perpendicular to both. That is the same geometric idea as dropping a height in simpler settings. Even in 3D chaos, perpendicularity still acts like the adult in the room. Today, the big ideas were perpendicular vectors, area, volume, planes, and skew lines. So one operation gave us algebra, geometry, and a mild existential crisis all at once. The cross product is basically the Swiss Army knife of 3D space.